Nearest Neighbor. This is simple and effective method to classify the classes, for example, to identify the fruit namely by color and density. Nearest Neighbor.
Here we have data of two fruits, apple and oranges in two-dimension graph.
We gave a new sample. Given a sample, come under the graph. The new sample will be near the apple, then it means it is apple.
If another sample is near orange in the new sample, it means it is orange if the sample is middle. We are not clear whether this should be apple or orange. If it is near the orange, then we say it is orange. K-nearest algorithm. We look at 3 nearest neighbor, we will see the majority and classify the sample. By observation we can say that by nearest neighbor says apple and 3 nearest neighbors say orange. What is K? We don't know what is right K, it is parameter we need to fiddle it. We need to identify K, basing on experience and adjust it by appropriation.
Distance. We take Euclid distance, or absolute distance. Is this distance is a more km, this changes the base. With no extra knowledge, we calculate Euclid distance and find out KNN algorithm.
Linear classification or regression. We have two-class classification problem, represented in two dimensions, samples in the first class and second class. Given a new sample, we need to identify whether the class is class 1 or class 2. Linear classification. Express this decision rule in extremely simple and effective with help of a line. This line is decision boundary represented as WTX, W1, X1 plus W2 X2 equals 0, X1 is first dimensions and X2 is second dimensions.
Let's just assume that x1 x2 equals 0, it means, graph, first coefficient is 1, second coefficient is -1 if WTX is less than 0, then come on downside, if greater than 0 otherwise upside. Decide as class 1. If WTX greater than equals 0 decide as class 2, if WTX less than 0. This gives us an effective way and extremely simple way of classifying with help of few coefficients W. W is coefficient, that is the parameters we are learning. Given the data, x, y, find W.
So we write this decision boundary as WTX equals 0, we kept the vector notation because same equation is valid for 2 dimensions or d dimensions. In practical problem we will work in d dimension.
Our decision rule will be sign, WTX, is positive or negative. We can say one class if positive or other is negative, so we don't implication, that which fruit is considered as positive or negative.
Please check the description for the demo, reference for the material. Let's load libraries from NumPy, Matplotlib, Pandas.
We're loading iris data and we're gathering x and y values. Here y values are the classes for the class.
We are splitting the test data by test size of 0.4, which means from the data, we are split it into 2 pieces. 60% rows are for training data, and 40% rows are for testing.
We are scaling the data using standard scaler, to normalize the data. In order to scale the data between 0 and 1, we use fit and transform function. Normalized data is good for building a model. To reduce the ambiguity of the high and low values of data,
we can implement KNN algorithm from Sclean library, and by using the predict function, we can predict the class of the input data. Here we are passing the trained data for modeling.
Confusion matrix. What is confusion matrix?
In machine learning and specifically the problem of statistical classification, a confusion matrix, also known as an error matrix, is a specific table layout that allows visualization of performing of an algorithm, typically a supervised learning one.
In this confusion matrix, of the 8 cat pictures, the system judged that 3 were dogs, and of the 5 dog pictures, it predicted that 2 were cats.
All correct predictions are located in the diagonal of the table, highlighted in bold, so it is easy to visually inspect the table for prediction errors, as they will be represented by values outside the diagonal. In abstract terms, the confusion matrix is, where P equals positive, N equals negative, TP equals true positive, FP equals false positive, TN equals true negative, FN equals false negative. Accuracy will yield misleading results if the dataset is unbalanced when the numbers of observations in distinct classes. Example, if there were 95 cats and only 5 dogs in the data, a particular classifier might classify all the observations as cats. The overall accuracy would be 95%, but in more detail the classifier would have a 100% recognition rate, sensitivity, for the cat class but a 0% recognition rate for the dog class. Here, from predicted output and actual output, data separated from the split, we can see the confusion matrix. With the confusion matrix, we can see true positive results of the test. With similar data, we can see classification report of the predicted data with actual and see other parameters of the confusion matrix such as precision, recall, score and support.
Finally, we can see accuracy of the KNN algorithm by calling accuracy score method of sklearn.
Please don't forget to subscribe my channel Meeraj Kanaparthi. I also upload latest trends in research in live videos, so please click on the bell icon to get the alert.